Good evening, everyone. Welcome to the Global Math Department. My name is Lee Natero, and I'll be your host tonight. Tonight, we're going to hear from Christine Lenghaus about proportional reasoning and the proportional reasoning using a double number line. Would everyone please introduce themselves in the chat window, telling us what you teach, where you teach, and what your Twitter handle is if you have one. Welcome from Ontario and Washington State. I see some familiar names in the chat room. Welcome, Heather. Welcome, Sherry. Welcome, April. Welcome, Tony and Jeff. If you're just joining us, you might want to click on the Handouts tab and download those files there that you can reference later on and use after the webinar. Welcome from India. Yeah. We are definitely a global math department tonight because tonight our speaker is from Australia. All right, before I introduce our speaker, let me explain how these meetings work. These meetings are recorded and are available within 24 hours after the meeting ends. To view the recording, you can use the same URL you used to get here tonight. The global math community prides itself on being friendly and supportive. The chat room is available for topical and general conversation throughout the meeting. I'll catch your questions for the presenter, so don't worry that she will not notice the questions in the chatter. So tonight, our speaker is Christine Lenghaus. And as I said, Christine is a secondary school math teacher who has taught in government and private schools in both regional and metropolitan Victoria, Australia. She currently teaches in the technical and further education sector, which is government run. Previously for the Global Math Department, she has presented 2 webinars on visual strategies for teaching mathematics. I'll be posting the links to those 2 webinars in the chat later on. She has presented at the annual Mathematical Association of Victoria Conference for 10 years, the Queensland Association of Mathematics Teachers Conference in 2016, and in April 2018, she presented at the BCME Conference in the UK at Warwick University. Last year, she went interstate to South Australia to present and traveled across the state of Victoria, sharing her passion for teaching and learning maths when not in the classroom. Welcome, Christine.
Thank you, Lee. Thank you so much. I hope everybody can understand my accent, and welcome to 2020, everyone. So if there's something that I say that you don't understand, or if I speak too quickly, just put something in the chat and I'll go over it again. We tend to say maths in Australia, so if I say math instead of maths, you'll know what I mean. So when I first started doing these presentations for Global Math, this was the first one I did 3 years ago, and I started with this one, and it was like, can you see the old lady and the young lady in that picture? And it's the fact that you always have to program to see the young lady or program to see the old lady in your brain. So I'm from Australia, Francis, and yeah, it's that programming. It's what do the kids actually see in their brains when we're talking about maths. That's why I focus so much on the visual. And this picture from Pam Harris, if you want to do a great PD on double number lines. On ratio tables, she does a really good one on that one. And if you look at this picture, you can see there's 1/3 plus 1/2. And you can see that if that's the picture that the children have, then 2/5 is pretty obvious, isn't it? And if we only teach them how to do counting, so 13 take away 8 and 8 take away 6, that's not actually teaching them to be additive thinkers. That's actually teaching them counting strategies. So you need to use a double number line to actually get them to do additive thinking. And we need them to move on to multiplicative thinking, in that we don't want them to skip count 3 plus 3 plus 3 plus 3 or try and do double 17 and one more. We actually want them to say, oh, 3 times 10, 3 times 7, I can then add those two together. So that's where I'm now trying to move into that proportional reasoning type thinking. And this is some thinking from a year 8 boy, so that's about 13 years old, that I had several years ago. This is Marcus. We had a box of chocolates. You can see that there were 15 chocolates that had filling, 9 that didn't. So there were 15 out of 24. So the part to the whole is 15 out of 24, part is 15 to 9. And I said, so what percentage is that? And so you can see there that Marcus was thinking, well, there's a 60 there and a 96. So we did 4 lots of 15 was 60 and 4 lots of 24 was 96. But can you see what he did with the 64 and the 100? What did he then do? Can anyone else hear me? Okay, so can you see that all he then did was he just said, oh, I'll add 4 to the 60 and I'll add 4 to the 96. And he went, well, that's 64%. So he was in that stage of, you know, additive thinking, multiplicative thinking, all of that, yeah. And so you're going to see this confusion, this rewiring in their brain, that programming that's got to happen. And it's not just a click your fingers and it's done. You know, it takes a bit of practice. Yeah. So that was Marcus. And so let's talk about this idea of multiplying and scale factor being times as much. So one afternoon we go and shoot some hoops. I managed to shoot 5 and you shoot 3. Who's a better shooter? Exactly, Lee. It depends on how many try. It depends on the size of the unit. It depends on what's the hole. I could have spent all day trying to shoot 5 goals. You might have got 3 goals in 2 minutes, depending on how you were. So it's not relative to anything. So it's not in proportion. Exactly. That's exactly right. So if I said I had 20 attempts to shoot those 5 goals, but you only took 8, now you can sort of get an appreciation of who's the better goal shooter. Yeah. And then you can start to see that, you know, well, 3 out of 8 is better than 5 out of 20. And then you start to get that part whole relationship, that being in proportion and so on. So we want them not only to know that, for example, 12 is 8 more than 4, but we also want them to know that it's 3 times bigger than 4. And that's the idea between scale factor times as much. And that's why I use a double number line to show that proportion, that relative size. It doesn't matter what digit I actually put up the top there in that diagram there with the times 10 times 10. If it was a 3 and times it by 10, it would be 30, times 10 would be 300, times 10 would be 3,000. It's the times 10 and 1/10, or dividing by 10, that is the scale factor every time, because if I did it with the 3, 1 would be plus 27, plus 270, plus 2,700. The plussing is not the pattern. So it's that idea of multiplication that is so important, and number lines are really important for that sort of thing. Whoops, let me press the right button. Some of the things I've done in class for this idea of scale factor, So the top one is just making a pattern and actually just putting it in a table. So you can use your pattern blocks if you've got very young kids. I've done the scale factor diagram one, where the kids basically get one sheet of paper and they have to draw themselves to scale on that piece of paper. And that turns out to be quite funny, which is good fun for the kids because they always love to be drawing and then measuring and all sorts of stuff. The one on the left there with the elastics is one from a lady named Jill Cheeseman from Monash. And she had 4 different types of elastic from the shop. So there was hat elastic, sharing elastic, and a couple of other sorts. And so we looked at this proportional times as much scale factor idea by how far the elastic could actually stretch. So does the elastic only stretch at the start and at the end? So we marked 5 centimetre marks on the elastic with a texter, and we looked at how far each of those actually stretched. And that was a really good exercise for the kids to see that, you know, not all the elastic is the same, and just to get that feeling for times as many. It stretched, you know, 1.5 times as much, that idea. There's a great little video on dominoes, which you can watch later on, but each domino is 1.5 times bigger than the previous one. And if you had 29 dominoes, how big would that last domino actually be? So it's not about adding on, it's about multiplying. So when you measure the pencils, you know, Christine's pencil is half the size of Lee's pencil, and so on and so on. So feel free to ask questions if you've got any questions at any stage. This was another one I did in the classroom, you know, the little the Russian dolls. We had a look to see if that they were in proportion. Matt Vaudrey's got another great activity called the mullet ratio. We actually put our own photos in there as well of our 80s hairstyles with our, you know, big hair and so on. It was quite funny. The kids thought that was funny. And that other one there is a great little book. Thanks, Lee. If you hopped like a frog, there's a PDF, and it's like, if you hopped like a frog, how high could you jump? And it's that idea that it's a scale factor thing. So there's just a few of the different things that I've done. Here are some examples when we talk about congruence and similarity and so on. So the Band-Aids are actual size, just to show the kids things that are real life. You know, I mean, when they put cereal on the box, you know, there's this great big, you know, piece of cereal jumping out, but, you know, it's like 3 times the actual size of a piece of cereal. M&Ms, it actually says on the box, product not shown, not actual size. You can see there's the biscuits. There's lots of examples for those sorts of things. And I've just put some different ones in so that you can see sometimes it is actually proportion, but sometimes it's not. And the kids need to have examples and actually have to think about, well, is this proportion or isn't it proportion? You know, and you can find these things all over the place. There's a little, I don't know if you can see the little Google Maps there, but I actually looked and I was like, I was 45 minutes from home and 47 minutes from the school that I previously taught in, but the distance wasn't the same, so it's still not in proportion. Well, why wouldn't that be? And, you know, one's to the city, one's to the country, all that sort of stuff. You know, there's a haircut there that I took when I was in the UK, £99 for a short haircut and £149 for a long haircut. You know, the juice bottles that you see, they look similar in that they've got the same sort of shape and their lids are actually the same size, but they're not similar because it's not in proportion, because otherwise the lid on the larger jar or the bottle would be much, much bigger. So there's lots of those sorts of examples that you can show them. This was one I did with my 13-year-olds many years ago. I just took in a packet of Weet-Bix, the empty wrapper, and I just wanted to see where their proportional reasoning was at, how they actually did it, what did they know how to do. We just did lots of questions, and that's just an example. Yeah, the little shoppy things are, yeah, I know, I've got heaps of those too. Thanks. So when I did this, so I had a really high year 2. So that's, say, 8-year-old kids. And I came and they wanted me to do something a bit different with them. So I thought, all right, let's go in with my turtle. And I just told these kids, my turtle gets fed 45 grams of food every 3 days. And I thought I would start double number lines like this. And the kids, we were sitting in one of the corners on the side, and they all had their little mini whiteboards. And so we started talking about my turtle. I don't have a turtle. And, well, what does that mean, 45 grams every 3 days? And, they were trying to work it out. And this whole idea of proportion is you can't do take away and add, because what do you take away? If I take away 2 days, how much do I take away on the 45 grams? Do you see that you actually have to be a multiplicative thinker to be able to access this proportional reasoning? And it is so important that the kids can actually divide, and this is the skill that they actually fall over with because they can't do it. So these kids said, oh yeah, miss, that's, 1 day's 15 grams. And the Domino's one, I can't remember, I will find it later, Adina. But the turtles, it was 1 day was 15 grams. So I said, well, how many for 10 days? How many for 20 days? I said, but what about for a month? And then the kids were like, well, is that 30 days? Is it 31 days? Is it February with 28? And I said, so we had all these great discussions on, well, if I go on holidays for 3 months, will a 1 kilo tin be enough to feed my turtle? Or will I have to leave my friend 3 tins? Or how much would I need to leave? So that was the start of my proportional reasoning. I didn't actually call it all of that, 10 years ago when I was doing it, but and I discovered it didn't work as good as I wanted it to, because the natural tendency was to put it in a ratio table type idea. So then I came, Mike Askew, who's a fabulous guy in the UK, if I say to you, if 5 cars go by and then 4 cars go, how many cars go by? And if 5 cars go by, how many wheels is that? Yep, thanks, Heather. And can you see the difference in thinking? So one is an adding and one is a multiplying. Thanks, Shelley. Beautiful. Thanks. It's just starting to come through. Can you see the difference in thinking? One is about adding and one is about multiplying. And even just saying how many, it's not even a division problem, right? But the implicit message in that is that 1 car has 4 wheels, right? And to make it really explicit that it's how do we get that to work, I would often write 5 dash dash equals 1, 20 dash dash equals 4, because the kids who aren't the multiplicative thinkers just go, well, it's a takeaway 4. And I said, but that doesn't work on the other side, does it? Okay, 5 takeaway 4 is 1, but that doesn't work, does it? Yeah. So they have to actually get to the point, and in the beginning you need to write these a lot on the board, because the kids, you're actually trying to program what they're thinking effectively, that it's 5 divided by 5, it's 20 divided by 5, and you can see that I divided by 5 on both sides, and that's why it works, because then they're in proportion. Yeah. So there's some double number lines. Hopefully you've got your pen and paper and a calculator if you want to. How much would it cost to buy 1 egg, 1 donut, or 1 box of juice? So I want you to have a think about which side is the 1 on when I say 1 egg, 1 donut, or 1 box of juice. Yeah. Yep. Yep. So, unfortunately, I thought I'll just do it like this. It's where is the unit, not the money? Yeah, where the unit is, sorry. Yep, I read that. Yep. So you can start to see, you can get that idea and have a conversation about one egg would cost 33 cents, one donut would cost 83 cents, one box of juice would cost 75 cents. And you need to let the students work that out. So this is the start of those double number line ideas, and you can compare anything that you like. If I asked you, how much would you be able to buy for $1 for each of those, then, yeah, you'd put it on the money side, wouldn't you? And you get this idea. So you can start to get an appreciation that $1 would buy you 6/5 of a donut. So it's one donut and another fifth of a donut, or $1 would buy you 3 eggs, or $1 would buy you 1.3 juice boxes, which, you know, doesn't really, but just to give you an idea. And it's really good when you do stuff with food, because often the little unit price and so on is on there, so that also helps as well. So here's one that I did, and I've done quite a number of times. I actually walked into class with 4 blocks of chocolates, a 55-gram pastille roll, a 50-gram snack bar, 200-gram block, and a family-sized 350-gram block. That's a gram, not a gam. And I said, which one would you like a piece from? Which would give you the most chocolate? So if you just, and all I put up was, I think, yeah, I gave them that sort of an idea. So the serving size was 25 grams, and there were 2.2 serves in a packet. And I just said, A, B, C, D, give me which order you think you would get the most chocolate from. So I just said, actually, before I even showed this, I just walked in with the chocolate. So knowing A, B, C, D, what would give you, if you can picture a block of chocolate, which one would give you the most chocolate if you took one piece, one cubicle or one square or whatever you call them? Yeah, that was the question, Lee, because you don't know the size of the piece, you don't know the size of the unit, right? They just had to guess. It was estimate. Just what's your chocolate guessing like? What's your chocolate sense like? And we did about the cost of the serving as well, Fran. And yeah, it does depend on the size of the piece, right? So then, you know, once they'd all had a guess, I then said, okay, let's have a look and let's get some mathematics happening. So the 55-gram pastille bar had 16 pieces. The snack pack of 50 grams had 7 pieces. The 200-gram bar had 40 squares, and the 350 had 64. So then we looked at how many grams do you get per piece? And you can see that the snack one, you get a lot more chocolate. Yeah, well, they're not so much the serving size, but yeah, it was a piece. And I don't know how chocolate comes in America, but ours comes in like a big block, and you can bust it into little pieces, and it's like pre-divided up. And I just, just started, because the kids get confused about what they've got to divide and where's the one and all that sort of stuff. So, there was a good discussion around that sort of stuff. So now let's get some double number lines happening. So here's a double number line. And I've got 60 songs. It could be $60. It could be $12. It could be whatever you want it to be. 12 of them are by one artist. What percentage is this? Right, so, often express 12 out of 60 as a percentage. It's that idea. Yeah, So you can start with, well, where would 50% be? Where would 25% be? Where would 10% be? Those sorts of ideas, to get them in the mode for the double number line. So you can see I've put 0 down the bottom. I've put 100% in this case on the top right, 60 songs on the left. I always give it a heading: songs, percentage, dollars, grams, whatever it is. The percent symbol doesn't go next to the 100 because it's actually an operator. So I very deliberately write it like that. And so what I'm saying is that 12 songs represents some sort of percentage. So I'm trying to structure their proportional reasoning. It's now compared to 100. Where would that 12 be? Okay, so then I say, okay, let's see what we can actually work out. I can't actually work out on the right-hand side what S is until I've worked out what's on the left. And I say, and if I knew how to go from 60 to 12, I would be absolutely sure that I could do that as well. But if it was 13, it's not a nice number. So I try and show the kids the way that works for every time. So I say, okay, if I've got 60 songs, how would I get to one song? Because I know everything on the left, and I choose to start at the 60 because I know both the 100 and the 60. I can't start at the 12 because I don't know what S is. So I start at the 60, and if I had 60 songs, yep, exactly. And then you'd still have to divide the 100 by the 5. So it depends on how they think, and if they can do that, great. So can I divide by 60? Yes, I can. Now, how do I go from one song to 12 songs? I have to multiply by 12. I used to, at the very beginning, I used to put both red arrows in and then do the green ones on both sides at the same time. So I'd literally mirror it. But what I found was that kids would try and work out the value of what percentage one song was. They were trying to do 100 divided by 60 and getting all confused. So I learned just do one side first and then put in on the other side as well. So that's how I do it, because I found that actually works. It's structuring the kids' thinking that's really important. So I say, okay, well then, okay, how many songs? If 12 songs, what is that as a percentage? So follow those arrows back from the start of the S. So I'd follow the green arrow backwards and then the red arrow. And I would say I'd do 100 divided by 60 and multiplied by 12. Or I can write it as 100 divided by 60 times 12. You can see the 12 out of 60 times 100 that we would traditionally tell students. Just multiply by 100 because that's what percent means. When we've said to them every time percent is out of 100, which is a division. And so this way you structure their thinking and they can work out that it's actually 20%. So if I had have done 100 divided by 5, yes, I would have also got the 20%. But this works whether it's 17%, 3%, 0.5%, whatever it is, it's a tool that they can use. So I think of ratio tables as having a hammer, and this is then having a saw. And sometimes it's useful to have a hammer, and sometimes it's useful to have a saw. So that's actually how a double number line works. And then it's just a matter of which one's missing, which one do you need to work out, and where do you put the one, and so on. And once you get that thinking, they become very, very powerful. On tests, there are some rulers that I've made. And yeah, and Patricia, I want them to see eventually that it is just the fraction times 100, but I'm not going to tell them that. And that's the cool part. You know, if they come to that conclusion, then that's great. And if they don't, they've still got something that they can use whenever they do percentages. So on tests, where I share my resources, there are these things called rulers, and you can see there I've got A's and M's. So one's additive thinking and one's multiplicative thinking. So the first one says the cost price of an item is $60. The sale price is an increase of $70 on the cost price. What is the sale price? So there's two ways of thinking about that. You can say, well, what is 70% of $60? And work that out, and then you'd have to add it on. So I'd set up the double number line, I'd work out 70%, and then I'd still have to add on, in this case, $42 to be $102 that the sale price would be. If I was a multiplicative thinker, I could say, well, if $60 is 100%, I actually need to know what is 170%. What is the dollar amount of 170%? And again, I'd start and I'd work out what 1% is, and I could work out 170, and I would do exactly the same on the other side. And that scale factor of 170 over 100 gets me the $102. So it depends on if you want to know how much was the item marked up by, $42, you know, or you can just see straight away that the total price is going to be 102. So you can see those examples have different ones that are missing that I've just set up so that the kids, I just laminated these, and you can see where I put the hole through, and they could have them as a reference guide if you like. I have a whole heap of proportion ratio type examples, and I thought if I try and do all of these in a webinar, it'll take me 3 hours. So I just made some videos with them. Would you like to see one of them done, or the last one in black is probably the most interesting one? Let me know what you're thinking. If you're happy, I'll just keep going. If you want me to do one, I can try and share a screen.
Christine, I think we have time if you'd like to share it. Would you like me to share it? I can do that.
So what will you share?
The last one that you mentioned in your list of 3 YouTube links there.
Yep. So if I start sharing my OneNote,
you know, I'll take care of it from my end. While I'm queuing it up, do you want to describe what they're going to be seeing?
Yeah, I can. If you, yeah, yeah, okay.
I think this is the one. Is this the one?
Is that the last one? No, it's the third one.
Okay, let me find the third. It doesn't show me the full list here. This is.
Yep, that's it.
That's it. Okay. You want to describe briefly what they're going to see?
Yeah. So I would go into class with little cubes that interlink, or lollies, or whatever else, and I would say, or you say use dollars as an example. I've got $45, 45 M&Ms to share, 2 for me, 7 for you, 2 for me, 7 for you, and I would physically share those in front of the kids to show them what they would actually get. Do you hit play, or?
I'll hit play here.
Okay.
Here's the continuation of our example of
Evan, the
decreasing
hard
62,000 to 40.
Sorry, go. Yep.
Yeah, 48,000. Looking at some other thinking that we. That's why I use double number line. Yes, you can do it like this in a table when they're easy numbers, but they're not going to always be easy.
Oh. Why isn't it working?
Easy
Chris,
numbers.
you'll need to
So
mute.
what I'm saying is 45 lollies, 9 shares. Right? And I want to know what 2 shares are worth and what 7 shares are worth. So let's have a think, right? Because that's what I'd like to know, how many lollies there are. So that's you and this is me. Okie dokes. So I say, left or right, where's the one? On the left. And let's, far out, Brussels sprout. Sorry, meow. That's what happens when you try and scroll. So I go from the 9 shares to 1 share. So I have to divide by 9, right? So that means I'm going to divide this by 9. Actually, I take that back because I never have done that yet so far on the same side because it mucks kids up. So I'm not going to start now. So times by 2. So if I know what 1 share is, I want to know what 2 shares are. If I know what 1 share is, I also want to know what 7 shares are, right? So now let me just put this in here. Divide by 9, multiplied by 2. I'll do that one first. And I'll actually do that one in red actually so that it's very noticeable which one I'm doing. So me, look at me, right? I started at 45. And I divided by 9 and I multiplied by 2. Right, so 45 divided by 9 is 5. So I would have done that 5 times. 1, 2, 3, 4, 5 times. So that's a total of 10 lollies. You, on the other hand, let me do that in purple. You, on the other hand, received 7 shares. So you had, geez. Come on. You can do it. Sorry. We went through a lot of examples, didn't we? There we go. So you on the other you on the other hand, let me try and do that very carefully, had 45 divided by 9 and multiplied by 7, which gave you 35. My apologies for the jumping screen. That's how you actually do ones where you share things in a ratio using a double number line. So I hope you can see that the 10 plus the 35 gives you the 45, and it doesn't matter as long as you work out how many shares there are each time you do a share. That's a roundabout way of saying it. So 2 for me, 7 for you. That's 9 per time I'm going to share. And I will leave it at that. If you've got any questions, please feel free to contact me.
Okie doke. So the question was where in the learning progression do the learners have, Jill, I always use different colours to match what I do. I learned that was a great way for kids to scaffold it. Evan, if you've got kids that aren't multiplicative thinkers and are still trying to do adding and subtracting, that's where they'll fall over and they'll try and do 9 take away 8 equals 1. Like the example that's on the screen. Can you put my screen back on there, Lee? I'm not sure how to do that. It depends on where your kids are, where their thinking's at. Beautiful. Thank you so much. You know, if they're a bit wobbly on the multiplicative, you know, they'll struggle to say, well, where's the 1? And you have to talk them through what am I trying to find out? Am I trying to find out percentage? Am I trying to find out dollars? You know, they are not easy to learn, but once you learn them, they are easy to use. And that's the getting the kids to be able to, you know, easily use them. the best success I had with these was one student who at year 9, so 15, 16-year-old, the computer program at the particular school that he was using was still making him do fractions and stuff like that. And he wasn't getting anywhere other than frustrated. And so I scaffolded his thinking with these double number lines, and he could tell me percentage discount, percentage increase, all of those things by thinking through. So the first point you start with is you draw the double number line and put the zeros in, because everybody can do that. And then you start to think about, well, what am I actually doing? Is it dollars? Is it percent? You know, where's the 100%? You know, what do I know? That sort of thing. Does that answer your question, Evan? A little bit? Yeah. Yeah, I do, because if it was 2 for me and 6 for you, so it would be 8, and I'm trying to share 45, whatever it is, $45, you need to be able to do it with difficult numbers. And, you know, you can start off with the nice, easy numbers, but I want the kids to know how powerful that double number line is, in terms of I can throw any numbers at you and you'll be able to work it out. You can think it through. Cool. I'll keep track to see if you've put any more comments in, but I'll just keep going with this one here. This was one I did last year, not earlier this year. I took in these drinks and I said to the kids, tell me which one's got the most sugar in it. And I said, you just write the letters down, you know, A, B, C, D in the order that you think, from least amount of sugar to most amount of sugar. And what's the problem with that? Exactly. That's exactly it. Yep. They're not the same sized whole or unit or whatever you want to call it. They're not proportional amounts. And so you've got to go back to proportion. And you've got to go back to, well, what's a suitable sized unit? So we decided on 100 mils. And that's, you know, because in Australia we use metric, so 100 mils was a good thing to do. So that was the example that we all went back to, 100 mils. And if I did this again, I would very much more deliberately choose different sized containers. So the little fruit box, which is C, is a 250 mil, and A, which is a Coca-Cola can, is 200. B is a standard size can here, which is 375 mils. But I try and find something that was a little bit quirkier, because all of those tend to be easy to get to the 100. Yeah, it is, you know, the kids were just like, oh, wow. And then I said to them, okay, so we worked out, you know, how much sugar was in each one. And then I said, okay, so how many teaspoons is 20 grams of sugar? So you tell me, what's the smallest and the biggest number that you think 20 grams of sugar, how many teaspoons is it between? And I just made them have a guess and, you know, get in the ballpark. So, you know, how many teaspoons are there in 20 grams of sugar? It's maybe a bit hard when you do, I don't know, you do ounces or something. So do you want to have a guess? I think it was 8 from memory anyway. But it might come through and it just might be a little bit delayed. Okie dokes. So at the moment, McDonald's has an ad, and I did this one many years ago. This is Nick who drew those pictures. Nick, I said to them, how much does a Grand Mac weigh? You know, if there's a Big Mac and now there's a Grand Big Mac. And so Nick Yeah, Flanny, it's actually, I think it was about 8, I think, like maybe 5, something like that. Yeah, nice guess. You're in the ballpark. And I said, okay, so how many grams is there in a Grand Mac? How many grams is there? And so Nick said to me, he was drawing, and I said, what are you doing, Nick? And he goes, I'm a visual learner, miss. And he had to picture it in his head. So how many grams are there in a Grand Mac? Do you have a guess? Nice guess. Yeah, oh, Matt, you're all over it. But you know what I did? I thought 150 was too nice a number, so I said it was 151. So I set up the double number line. Thank you for guessing, everyone. Thank you. I set up the double number line and I've got grams on one side, percentage on another, put the zeros in. I know that 100% is 90 grams. That's the original one. Yeah. So I want to know oh, nice, lucky guess. I want to know what percentage increase that is to go from 90 to 151. Right, because if it had been 150, I think it would have been too easy for some kids. So I thought, righto, let's see what they can do. So then my question is, okay, I've set that double number line up. I know 100%, 90 grams. I want to know what 151 grams is. Which side is the 1 on the left or on the right? I'm hoping that most of you said left. Yep, thanks, Lee. It just came through. Cool. So to get from 90 grams, I go to 1 gram. How does that happen? It has to be a divide by 90. If I know what 1 gram is, can I work out what 151 grams is? Yes, I can. So I have to say 1 times 151 is 151. That was the one that I had back with the cars. So you might even need to write that on the board. Once I've set that up on the left-hand side, because that's where I know all the information, and I'm trying to work out the stuff on the right, I have to say to myself, do I start at the 100 or do I start at the P? Well, I can't start what I don't know, so I have to start at the 100. So I'm going to do exactly those same arrows there to work out what P equals, what this percentage is. And the way I do it, I then write on the board P equals, and I say, let's follow those arrows backwards and see where we started. Where did I start? I started at the 100. What happened to that 100 is it was divided by 90. And then it was multiplied by 151. So this is about the scale thing. And it would work out that that is 166.8%. And that means that going from 90 grams to 151 grams is an increase of 66.8%. So adding that 61 grams means you're adding 66.8% increase in the weight of the Big Mac. Is everyone okay with that? Please remember, it's the first time maybe that you've seen a double number line, and there's lots of wiring that needs to be created and programs to write into your brain, and it does take practice, but the more you practice it, the better you get at it and the easier it gets, and and off you go. I'll show you some of the stuff that Liam did with, I know so for example, so that's the Big Mac one is there on the left. That was my board that I took a photo of. If you've got something that's got an increase, a bonus of 25% extra, you can set that up on a double number line. You can set up fractions on a double number line, you know, for the file size, you know, if it's loading and that sort of stuff. This was what Liam did. One day I had a wrapper from the boarding house where I was teaching, and it said, it's now 40% bigger and it's now 180 grams. I said, Liam, how much was it originally? So in that case, yes. Sorry, Harriet, do students ever want to know what? Yes. Yeah, that Harriet, that question is what I first stumbled over, and that's why I very deliberately do all the arrows on one side and then all the arrows on the other. And you just have to say to the kids, well, what do you know? What do you know? And then I started using colour. And so by the time I got colour and, you know, doing it on the one side, I had more success. It is a difficult concept for them to get if they've never done it. Start back with the single ones, you know, with the, you know, my turtle has 45 grams in 3 days, you know, how many cars, get them to bring some groceries in and look at, you know, packets of stuff and all that sort of stuff. Okay, so Flanny, if I had this one, and this is a tougher one, this is a much harder one than the ones earlier, I say, okay, it's now 40% bigger. Do you know what it was originally? No, I don't know what it was originally. Well, okay, so if I started at 100%, that's the mass that I don't know. And what did it go up to? Well, it went up to 140%. And how many grams was that 140%? It was 180. You have to just keep, rather than telling them 180 grams is 140%, they actually have to think that through, because they have to own that, because that concept is in when you add tax on, all a percentage increase, all of that. It's a big idea, yeah. So I've got my zeros. I know that 180 grams is 140% because it's 40% bigger than what it was originally. And what I want to know is the mass. How many grams was it at the beginning at 100%? So I say, okay, do I start on the left or on the right? Yes, the one is on the opposite side. Yep. Did I put that? I did that on the wrong side, didn't I? Sorry, it should be on the other side. Thanks, Katie. Nice pickup. That one should be on the other side. Yep. So, oh, sorry, my bad. That one should be under the 100. So if I start at 140, thanks. Yep. So if I start at 140, because I know both of them there, can I draw on here? Yeah. Oh, you did that, Lee. You're awesome. Can you scribble the other one out? Thank you. Awesome. So that one there now, okay, so that's where I know both things. I know 140 and I know 100. I know both things at the 180 and 140 level. And so if I go from 140%, can I go to 1%? If I know 1%, can I go to 100%? So one is a divide by 140 and one is a multiply by 100. And those same arrows go on the other side. Oh, awesome, Lee. Fabulous. And then you say, okay, let's find M. So I've traced those arrows back and the green arrow started at 180. What did the green arrow do? It told me to divide by 140. And then the purple arrow said multiply by 100. And that tells me that the original bar was 100, or the original sausage roll was 128, probably 128 grams, 128.6. Patricia, taking that step of 140%, they will wobble. It's like the one where I had with the chocolates at the very beginning, where the kids said, oh, 15 chocolates out of 24 is the same as 60 out of 96. So that's just 64 out of 100. It is really, that's the thinking. And that's why you can't use counting, adding, multiplying, because it's that proportion that you've got to get them to move their thinking on. That's the critical part. And it is difficult. And lots of examples, lots and lots and lots of examples. Yeah. So I'll show you some of the other stuff that I brought in. There was a bread that was for quick sale. It was now $1.87 and it was 25% off. And I let Liam go, and he just tried to take 25% off the $1.87 or whatever. He really just thought, and then he said, no, that's not right, is it? And then he actually worked out that he actually had 75%. So the $1.87 was 75% of the original cost. That's the hard thinking. That's the mathematics. That's the proportional reasoning. That's the, that's the thinking in mathematics. That's the hard lifting. That's the hard work. I don't drink Coca-Cola, but I've been collecting these cans because I thought there's got to be a maths activity in there somewhere. And so I just looked at volume to surface area. So that was another one we did. I've got 4 minutes, so I'm going to go super quick. Food. If you go down to the supermarket, give them an envelope, a big envelope, and just say, all the specials tags that you've got, please collect them for me. They will give you back a whole heap, right? So, and I just said to the kids, use these tags and save yourself $50. So the kids that need, a bit more scaffolding, they'll just pick the 50% off ones, or they'll pick the 25% off ones. Or you might say you're not allowed to use the 50 and 25%. We found errors in the tags, even, scarier. So get yourself an envelope, go down to your supermarket, they'll give you the brochures. It's a great little activity to save $50. I'll just zip through this one. Food is another great one because in Australia, per 100 grams is actually percent. Use those for double number lines. Really, really easy for kids to see examples of. The boxes that I draw for doubling, timesing by 4 and timesing by 10 just become what I use to teach the initial percentages. So 50%, 25%, and also 100%, 10% and 1%, because then they can work out things like 13% by having 3 lots of 1% and a 10%, because I want them to see those ideas. So I use boxes to do the basics. For example, 20% is 2 lots of 10%, 5% is a half of the 10%, 30%. I could ask you what 90% of $60 is, and you could see that it would be 9 boxes. I use a I use a slider, the number slider, to show them how the 60 divides by 10 and divides by 10. So that's on tests. And let me just quickly go through. You can do it with speed. You can do it with currency. You can do it with area. So these are 2 different ones for area. So the Maths 300 Task Centre has a great one on the Sphinx, the pyramid pattern. This one I got quite a few years ago. As you can see, it was about scale factor, about, dragging the corner versus dragging the side or the top. That's in the resources as well. This year I'm going to do one on volume of a sphere, because all spheres are the same, similar. So I'm just going to give them the polystyrene ball, and then they can work out what the scale factor is. So we don't want any of this sort of stuff happening anymore. And if you look at the notes, you'll see those additional places to look for handouts. If you want anything that I've put up on tests, go to tests, look at resources. Just remember, my house is a weird spelling, and click on search. And I just want to say thank you to the Global Maths Department for putting on such an amazing opportunity for people to share and care about maths. Lee's been amazing, and everyone else that I've dealt with. And thank you, thank you, thank you. I have 1 minute left if anyone's got any questions.
All right, thank you very much. That was a wonderful presentation, and I think there may be a question still that Evan had in the Q&A earlier. I don't know if he got his question answered. There was one question here.
Matt, in the beginning, yes, I should draw those much more proportional. But in the end, the kids just draw them however they want. Yes, you can relate it to y equals mx plus b and all of that other great mathematics, but I only had an hour. So you can link it into anything that you do with proportion. And this is not about inverse proportion. That's what ratio tables are great for.
All right. Let's see. I think that is it for the questions.
Thank you so much, everyone, for spending an hour with me. Have a great year sharing all your math love out there, and see you soon.
Thank you very much. And next week, we have up for debate, Exploring Math Through Arguments, and that is going to be presented by Chris Luzniak. So I hope some of you can return for that. That is recommended for grades levels 6 through 12. So have a wonderful evening, everyone. Good night.